you. Thank you. Thank you, SK Planet. Thank you for having the event, and thank you for the invitation to speak here. Hopefully, many of you have learned a lot of good technologies today, and thank you for your patience to wait for this session here. I just recently moved here from Irvine, California to Seoul, and so I'm really getting used to the weather right now. It's very cold here. So bear with me, please. My name, as mentioned, is Jeff Markham. I'm from Hortonworks. When the Hadoop engineering team left Yahoo a couple years ago, they formed a company called Hortonworks, and that's our company today. We have a 100% pure open source distribution of Apache Hadoop. And what I want to talk to you today about is the new features in Hadoop 2. Hadoop 2 has many new features. It's going to be difficult to discuss all of them in such a short period of time. So you see my email address, which is not up there, but I will give you my card. I'll make sure you have my email address. Please contact me anytime with any questions that you might have on Hadoop 2. So in the US, there is a popular book by an author called Jeffrey Moore called Crossing the Chasm. And what it refers to is a gap between people who are early adopters of a technology or early adopters of anything. The gap between that group of people and the group of people who actually start to use the technology for solving business problems, for using it in everyday IT life. And so when it comes to Hadoop, we feel like the period of about 2006 with the first open source of Hadoop till sometime around last year is a period of time right before the gap. That gap where it becomes readily used and used day to day in organizations across the world. The innovators, the people who are interested in technology, the people who just naturally want to have the latest and greatest technology, those are the ones who adopted Hadoop up until this point. And now for any technology to cross that gap and go into the mainstream, we need to have something that would propel them to cross that gap. And so right now, what we believe is that we are kind of at that period with the introduction of Hadoop 2. In Hadoop 1, we had batch processing. Batch processing, if you're familiar with Hadoop, batch processing was really meant to process a huge amount of data at web scale. Built at Yahoo, used by companies like Facebook, LinkedIn. This was the use case for Hadoop, but it was so effective at that use case that it became widely used in any number of different sectors, not just web companies, manufacturing, telco, retail, banking and finance. All of these industries began to adopt Hadoop to process huge amounts of data on commodity hardware in an extremely short period of time. Now, in order for Hadoop to cross that chasm, we really felt like there needed to be some enterprise-grade improvements to Hadoop 2. Instead of just a very efficient and a very well-performing batch processing platform, we felt like some of these enterprise requirements, mixed workloads, interactive query, reliability, point-in-time recovery for your data, multi-data center, being able to have Hadoop clusters in multiple data centers, not just in the same building, but across the globe. Zero downtime. All of these things are not in Hadoop 1. So in order for Hadoop to have widespread adoption and to cross that chasm, we felt like we had to spend a significant amount of engineering time creating the features that you see here in Hadoop 2.0. So for the mixed workloads, we're going to talk today a little bit about Yarn. For interactive query, we're going to talk about a project that we initiated at Hortonworks called Stinger. Stinger is really not just one project. It's a combination of a few projects that aims to make Hive, the standard SQL interface to Hadoop, 100 times more faster than it was when we first started. There are some things that I wish I had more time to talk about today, namely the improvements in HDFS. HDFS is the storage layer of Hadoop, and some of the improvements you see at the bottom of this list here. But one of the very well-known weaknesses of Hadoop 1 was the name node high availability limitation, meaning if you had only one name node, and if that name node went down, your whole Hadoop cluster is in trouble. Each Hadoop vendor had their own answer for that, but now that is built into HDFS. So we don't have to rely on specific vendors for solutions for this. It's all simply built into HDFS. Those things and other features of HDFS, like snapshots, like disaster recovery, and rolling upgrades of your Hadoop cluster, I'm going to have to not talk about in the interest of time today. And what I am going to focus on is something called Yarn. Yarn in Hadoop 2 was born out of the fact that, again, Hadoop 1 is a batch processing system. But people were still using it for multiple different kinds of workloads. In the screenshot that you see here, you see different silos of application types, different silos of workloads. We have in the middle a batch system with interactive jobs. That may be HBase, that may be Cassandra, that may be something else. But we don't want that runtime to compete with the resources of MapReduce, which is the batch processing system. So oftentimes what people will do is they will architect their clusters in these separate silos, have a separate cluster for HBase, have a separate cluster for Hadoop and MapReduce. And even though that might have been more efficient and effective use of your hardware and of your infrastructure, it wasn't ideal. It's obviously not an ideal solution. So what we did is we took a look at where Hadoop 1 was, which is a very simple architecture. HDFS, the storage layer, MapReduce has two responsibilities: cluster resource management and data processing. And this is where we took a look at Hadoop and said, we can do better. So we took a look at Hadoop and said, with MapReduce, we have a master server called the job tracker and a lot of slave servers called the task trackers. So with a job tracker, the job tracker was trying to do both of these things right here. It was trying to do cluster resource management, and it was trying to do the data processing. And it was getting bloated, and it was getting bigger, and it was getting very difficult to maintain and add more functionality to. So the idea was to separate out cluster resource management and data processing. Cluster resource management now is the responsibility of Yarn. And what that means is this. In Hadoop 1, when you had a MapReduce job, you would have just memory as a resource. You would not have CPU. MapReduce had no idea about the CPUs on your servers. MapReduce had no idea about the disk on your servers except what HDFS reported. MapReduce had no idea about the networking capabilities of your cluster. All it really had a rough idea of was your memory. And it didn't have a very accurate idea of your memory at all. It just had something called slots, a map task slot or a reduced task slot. That meant the number of map tasks or reduced tasks that you could run on a single server. And you as an administrator would configure that. And that is not nearly an efficient use of your cluster's infrastructure as what you need to have happen. So in doing so, we created that ability for Yarn to have a much more fine-grained control over your cluster resource management. Say, for example, you install a Hadoop cluster. Your initial cluster might be 50 nodes. Well, say maybe 2 years later, you decide to add to it. Are you going to add the same hardware? Probably not. You're probably going to have newer hardware, the latest hardware, with more memory, with better CPU, So how does Hadoop 1 manage that? How does Hadoop know about that? Today it does not. With Yarn, it does. Now you can have a more efficient control of your cluster's infrastructure. So what happens to MapReduce is that MapReduce now becomes an application built on top of Yarn. And it was the first application for Yarn. What Yarn has done is allowed this key block here called others. Others we'll talk about in a second, but what this means is now you, as an application developer, can start to develop applications for Yarn. It doesn't have to be just MapReduce applications. In Hadoop 1, when you had these different types of workloads, batch, online, streaming, graph processing, maybe even some in-memory data processing requirements. Again, oftentimes, these were maybe separate clusters or clusters that shared HDFS, the storage resources. And again, we felt like that was not an ideal use of the Hadoop cluster, not an ideal use of your hardware infrastructure. So where Yarn comes in is, again, we have the ability to run MapReduce, your standard traditional batch jobs, as a Yarn application. We have another project that we created at Hortonworks called TEZ. It's an open source project at the Apache Software Foundation, and what it originally was built for is to make Hive more interactive. And we'll discuss that in a bit here as well. But there are other applications now that we are also doing. We are porting HBase to Yarn, so that now you can run HBase on top of Yarn. Other processing requirements. Storm, we have a partnership with Twitter and Yahoo, and Storm is a SEP engine, a complex event processing engine from Twitter that was ported to Yarn at Yahoo. And so we support that also. And there's a number of different applications. You can build your own applications. They don't even have to be Java applications. So here's what it looked like for old school. This is the old Hadoop. How many in here, I usually hesitate to ask people to raise their hands, but does anybody in here have significant experience with Hadoop already? Anybody? Nobody? Well, this is what MapReduce used to look like. MapReduce had a master server out there called the job tracker. And the job tracker, again, that was the thing that was responsible for managing the resources of the cluster, knowing how much memory each node had, and also the data processing responsibilities, spreading out that job into different tasks among the task trackers. What goes away is the job tracker and the task tracker in Hadoop 2. Now we have a resource manager and node managers. And the resource manager does just what you would think it would do. It manages the resources of your infrastructure. Each node manager on each server reports back to the resource manager what type of resources are on that node. CPU, memory, disk, networking capability. All these things are available now to the resource manager. And you, as an application developer, now have fine-grained control over that. So whereas before, all that was the responsibility of the job tracker, now you as the application developer can tell your application how many nodes you want to run on. If you have a cluster of, say, 50 nodes, before, MapReduce would just take hints from you as a developer, but it would decide on its own how many map tasks it would use on that cluster. Now you as an application developer can say, I want my job to run on 2 nodes, to run on 15 nodes, 20 nodes. It's all up to you as an application developer. It's up to you how much memory you want to use. Do you use 500 megabytes of memory per node, 2 gigabytes of memory per node? Whatever you want as an application developer, whatever is available for you on that cluster, you get to decide what to use as an application developer. So the key benefits of Yarn are scalability. With the job tracker, we had a finite number of nodes that we could scale our Hadoop cluster to. The largest Hadoop clusters in the world scale out to about 7,000 or 8,000 nodes, that's it. And so with Yarn, we're able to scale that out far greater. We're able to scale it out at Yahoo up to 30,000 nodes. That's on a single cluster. And that's pretty impressive. Compatibility with MapReduce. You know, the big bang for the buck, the big benefit of Hadoop 1 was MapReduce, was the ability to do this parallel processing for free. You wouldn't have to spend a lot of money on hardware, commodity hardware only, open source. MapReduce was the big driver for Hadoop adoption. And so we wanted to make sure that MapReduce works the same way now as it always has worked. Improved cluster utilization. So that just is a recap of what we talked about just a second ago, which is before a MapReduce system, a Hadoop 1 system would only be able to use realistically maybe 60 or 70% of your cluster, 60, 70% of your memory, of CPU, and so on. And in today's world, that's not good enough. As good as Hadoop is and was at batch processing, we need to do better than that. And Yarn allows us to maximize the utilization of your cluster. New programming models. I have a talk that I give often to conferences on how to actually build a Yarn application. And one of the nice, exciting things about Yarn is that it allows you to build applications that are not just Java applications. Today, if you want to build an application for Hadoop, it's a Java MapReduce application development process. We have some abstractions over that. One abstraction over that is a SQL interface to MapReduce, which is Hive. We have a scripting interface to MapReduce, which is Pig. And we have a streaming capability with MapReduce that allows languages like Python and R and other languages to use MapReduce, but it's far less efficient. So with Yarn, it makes it much more efficient and much more native to run non-Java applications. That's the programming model. Hand in hand with scalability is the last point, agility. Agility means that not only can we scale that cluster out to a huge size, but our applications can use finite, very fine-grained control, very fine-grained resource utilizations for each application. So we don't have to just rely on that being calculated for us. We can decide in our own applications just how much of that cluster we're going to use. I mentioned that MapReduce was the first application that was built for Yarn, for Hadoop 2. We had to do that naturally so that we could still keep MapReduce as a key component of Hadoop. But the next application that was built for Yarn is ApacheTZ. And we're pretty excited about ApacheTZ because, again, it was part of a project or an initiative at Hortonworks called the Stinger Initiative. And one of the areas of Hadoop that is very competitive, depending on your distribution, is the SQL interface to Hadoop. Everybody has one. Everybody has an answer for one, or at least they try to have an answer for one. What everybody has used in the past was Hive. Hive is an open source project that is commonly associated with Hadoop, originally donated to the Apache Software Foundation by Facebook. It has become the de facto standard for SQL type operations in Hadoop. But Hive was never built to be interactive. Hive was simply built to make it easier to use MapReduce. Write some HiveQL code, which is very similar to SQL, and submit it to the job tracker and let it do its thing. And it was always built as a batch system. So what people want, though, is a more interactive response time out of those SQL type interfaces to Hadoop. And so ApacheTZ was built for that reason. The graphic that you see here kind of illustrates what used to happen in Hadoop 1 and what happens now in Hadoop 2. It may be hard to see in the back, but what we see over on the Hadoop 1 side is that when a Hive job is submitted, when you write a SQL script with Hive and submit it to the job tracker, that can be broken apart into different jobs. Each job might write its output to HDFS. HDFS would then do its thing to replicate that output twice. So you would have 3 copies of that data. That's a waste of resources, a waste of time. There's no need for that. So what we have in TEZ is a concept of always on, in-memory sessions that will run in memory, ready to parse your Hive script, do the processing of data, using the concept of data locality, and then do that all in a single job, so that we don't have a serial execution of one job waiting for another job, waiting for another job, and in between each job writing to HDFS. That in and of itself was a significant improvement to the performance of Hive. And I mentioned the Stinger Initiative. What the Stinger Initiative originally sought out to do was not just increase the performance of Hive, but to just increase the overall functionality of Hive. For example, Hive had certain storage formats. Storage formats like plain text file, record columnar files. What we had as a contribution to the Stinger Initiative was something from Microsoft called the optimized RC file. It's a file storage format that allows for far greater performance in query reads, far greater performance with compression, and again, it was donated by the community, by our friends at Microsoft. Also at SAP. SAP is also a partner of ours, and SAP is also part of the community of Hive, and they donated some analytics that you see down there, SQL analytics, windowing functions, things that will enhance the analytic capabilities of a native Hive query. And then Hive, in the Stinger Initiative, what we have done is try to make HiveQL more like SQL. It naturally never will be exactly the same because they're 2 separate systems. But right now, HiveQL is too different than SQL. And so what we have done is undertaken the effort to make HiveQL more like SQL. The goal of the Stinger Initiative was to make Hive 100 times faster. And with TEZ, we have done just that. What I hope to convey on this screen was the data types, the UDFs, and the windowing functions that are a part of Hive now. But what I'm going to do is I'm going to skip through this slide in the interest of time here and just go straight to this slide, which is our latest benchmarking capability. We have down here a URL that you can go to today to look at these benchmark results in more detail, but this is just simply one of them. So again, our goal was to make Hive 100 times faster, and we have almost doubled that goal already in just 9 months' time of work on the Stinger Initiative. And that's something that we're really proud of. We point to this as something that is proof that open source development is by far the best way to get quality software. There's no way any one company could have done this amount of work in 9 months' time. So one of the benchmarks that we show on the URL that you see on the screen is a query that does some pricing and inventory analytics. We compare it to Hive 10. Hive 10 was where the Stinger Initiative started, and Hive 10, by the way, is the version of Hive that people usually compare themselves to. So if you hear comparisons, say from EMC Hawk or Cloudera Impala or Facebook, what's the one they released last week, Presto, they're usually comparing to Hive 10. We are now at Hive 12, and with Hive 13 being released next month. Again, that is at a speed that you cannot find anywhere else except in the open source community. So when we compare ourselves and our progress in the Stinger Initiative, we compare it to Hive 10. That's where it began. And so in Stinger Phase 3, we're able to take queries that took minutes and bring them down into seconds that are more acceptable for real time when you're talking about the amount of data that we see here, approximately 200 gigabytes of data for that particular query. And that particular query had some analytics involved in it. So you can feel free to go read more about these and other benchmarking details in the URL that you see at the screen below. One of the things that we also are proud of at Hortonworks is that with Hadoop 2, we have packaged it as a pure open source system. So there are other Hadoop distributions that might include some proprietary bits of software. Our distribution comes all from the Apache Software Foundation open source projects because that's where we do all of our work. All of our work is done in these projects because, again, the original Hadoop engineering team from Yahoo, when they left to form Hortonworks. So they still do their work in the Apache Software Foundation projects, and we QA, we do some quality assurance on this distribution at the Yahoo cluster. The Yahoo cluster is the largest Hadoop installation in the world. It's in between 12 and 15 clusters with a total of 60,000 nodes. It's the largest one in the world. And so when it passes all the quality tests there, then it moves from becoming just the Apache Software Foundation project, and it moves to becoming the Hortonworks data platform. Everything you see there is open source. Everything you see is free to download today and start working with it today. You can start working with some of the features of HDFS2. Again, HDFS2 has some significant features to it, including name node failover, including name node federation. One of the many limitations of Hadoop 1 was the performance of HDFS. Originally, the name node acted as kind of a bottleneck for traffic going into HDFS. Now we have something called name node federation, where you are allowed to run more than one name node. We can have multiple name nodes serving up multiple requests from clients for HDFS reads and writes. That combined with the HA failover, that combined with snapshots, with NFS access, is something that is very key in Hadoop 2. The Knox project. The Knox project that you see here is where a lot of the security work for Hadoop is happening in the Apache Software Foundation. Another very simple feature of Hadoop 1 was the simpleness of the security. If any of you are familiar with Hadoop 1, security is very simple. Security is too simple. It's not full-featured enough. So we usually address that with architecture decisions in Hadoop clusters today. Now it's more formalized in the project called Knox. So what we have here as a package, QA'd at the Yahoo cluster, is the Hortonworks data platform. To get started today, what you could do is download the Hadoop 2 sandbox. What we have today is something that you can download and start using on your laptop today, either with VirtualBox or VMware, Player, Fusion, Hyper-V, whatever virtual machine that you wanted to use. You could download this today. It comes with tutorials for you to learn about TEZ, for you to learn about Yarn, for you to learn about Hive. I encourage you to download this and start learning Hadoop 2 today. So right now, I guess I'll close and take any questions that you guys might have.